This is CAIE A-Level Maths, Summer 2020, Paper 1, Variant 1, question number 9. In this question, we've been given the equation of the curve and we need to find the first derivative and the second derivative. We know that the equation of the curve is y equals to 3 minus 2x whole cubed plus 24x. In order to find the first derivative, we can write dy upon dx, which will be equals to. So we know that in order to find the derivative, we'll have to take down the power and multiply it. We'll need to subtract 1 from the power, and then we will have to multiply it with whatever the derivative is of the inside term, which is the bracket. So applying this will give us 3 into 3 minus 2x squared into minus 2, which is the derivative of the inside term, plus 24. Solving this will give us dy upon dx will be equals to minus 6 into 3 minus 2x squared plus 24. For a second derivative, we'll apply the same logic, and this will give us dy squared upon dx squared will be equals to minus 12 into 3 minus 2x to the power of 1 into minus 2 plus 0, and our final answer will be d squared y upon dx squared will be equals to 24 into 3 minus 2x. In the second part of the question, we need to find the coordinates of the stationary points of the curve. We know that if this is the curve, then if we draw tangent over here and a tangent over here, the gradients over here will be equals to 0, or in other words, the dy upon dx will be equals to 0. So we just found the first derivative. Let's copy it over here, and let's change the color. Dy upon dx will be equals to 0, and this will give us minus 6 into 3 minus 2x whole square plus 24. Taking it on the other side, this will give us 6 into 3 minus 2x whole squared will be equals to 24. We can first either open the brackets and then solve it, or we can just take 6 over there and under root the whole answer, which is what I'm going to do. So this will give us 3 minus 2x whole squared, which will be equals to 4. 3 minus 2x will be equals to plus minus 2, or we can write this down as 3 minus 2x will be equals to 2, or 3 minus 2x will be equals to negative 2. Solving this further will give us 2x equals to 1, and x will be equals to 1 upon 2, and this will give us 2x will be equals to 5, and x will be equals to 5 upon 2. Now that we know our x values, let's find the y values. We can take the original equation let's copy it twice and plug in the value of y. This will be y equals to 3 minus 2 into 1 upon 2 whole cube plus 24 into 1 upon 2, and this will be equals to y equals to 3 minus 2 into 5 upon 2 whole cubed plus 24 into 5 upon 2. So this will give us our y value. Let's just calculate our y value. This will give us y equals to 20, and this will give us y equals to 52. So our final answer will be 1 upon 2, or we can just write it as 1 upon 2 comma 20 and 5 upon 2 comma 52. For the last part, we need to determine the nature of the stationary points. So for that, we can copy the second derivative of the equation that we found in the first part. We can copy it twice. Let's just change the color. So for x equals to 1 upon 2, rd squared y upon dx squared will be equals to 24 into 3 minus 2 into 1 upon 2, and for the x value 5 upon 2, it rd squared y upon dx squared will be equals to 24 into 3 minus 2 into 5 upon 2. This will give us this will give us 48, and this will give us negative 48. So since this is a positive value, our curve will be positive, and this will be a minimum curve, and this will be a positive curve, which means it would be a maximum curve.